Welcome to a tutorial of Proflan YouTube channel. In this particular video, we're going to discuss linear momentum, whereby we're going to discuss what are the main aspects that you have to understand as far as AS physics is concerned. Now, the first thing that you need to understand in this area is that momentum is equal to mass times velocity. The formula for momentum is mass times velocity, which is denoted as P is equals to mv. And from here, we can be able to see that the unit for momentum is kilogram meter per second, because you are multiplying velocity and the kilogram and mass. You are multiplying velocity and mass. It means that the unit now becomes this. Next thing that we can identify here is that momentum is a vector quantity because it has both magnitude and direction. Now, once you have noted that, once you have identified that, you really need to accept that there are types of collisions, because when momentum once we have understood the concept of momentum and we have known the units and the formula for calculating momentum, the next area that we need to work on, or the next area that we need to mention, is also the principle of conservation of momentum. Principle of conservation. And under this part, you are going to realize that momentum before collision is equal to momentum after collision, which is the principle of conservation of momentum, whereby we're going to say momentum before collision is equal to total momentum after collision. And this is provided there is no external force. Provided no external force act. Under this area now, we'll also notice that there are types of, after mentioning the principle of conservation of momentum, we have elastic collision, and in elastic collision, both momentum and kinetic energy are conserved. So that means that momentum before collision in elastic collision is equal to momentum after collision. Also, kinetic energy before collision is equal to kinetic energy after collision. We also have what we call inelastic collision. And in this, we are going to say only momentum is conserved. Only momentum is conserved. Kinetic energy is lost in form of heat. And sound. So if you want to check, and if you would like to check whether a collision is elastic or inelastic, what you need to see or what you need to focus on is to check whether kinetic energy is conserved. So if you find that kinetic energy is conserved, or kinetic energy before collision is equal to kinetic energy after collision, that will mean that this is an elastic collision. But if you find kinetic energy is not conserved, which means that kinetic energy before collision is not equal to kinetic energy after collision, then that type of collision is known as inelastic collision. Now, having looked at that, having mentioned that, we are going to look at collision in one dimension. Now, for instance, we have an object A which is moving at a speed of 4 meters per second, and we have another object B which is moving at a speed of 0 meter per second. Then you are told that the mass of this one is equals to 5 kilograms and the mass of this one is equivalent to 2 kilograms. Then after collision, this is, we can identify this as before collision. Before collision. Now after collision, A move in the same direction at a speed of V, and B move the same direction as A was moving at a speed of 1.4 meter per second. Using the principle of conservation of momentum, find the speed. Using the principle of conservation of momentum, we are expected to find V, and that is actually 4 marks to do that. Now the solution for this will be applying the principle of conservation momentum, and we're going to say that momentum before collision is equal to momentum after collision. So we're going to say momentum before collision for this object is going to be what? Momentum of A before they collide is going to be, because we can say momentum before equals to momentum after. So we are going to work out this by focusing on the momentum before the first object. Now let's look at the first object was moving at this speed and the mass was this. So we are going to say before collision, momentum of A was 5 times 4, then plus momentum of B, because B was at rest, yeah, we are going to say it will be the mass is 2 times 0 is equals to, after now they have collided, A will move with a velocity V. So we are going to say that at that given point, the velocity of A is V and the mass of A remains to be 5. So it will be 5V plus object 2B moves at a speed of 1.4 meter per second. So we're going to say the mass was 2 times 1.4 in that regard. So we are going to realize that this is going to become 20 plus 0 is equals to 5V plus this becomes 2.8. Then we can now be able to use we can use algebra for math, and then we can be able to say this is going to be 5V is equals to 20 minus 2.8. This is a 2.8, and then this is going to be 5v is equivalent to 10.2 divided by 5 divided by 5 at that given point. So that is exactly what you're going to do. And then if we divide that by 5, we are going to get our answer as 3.44. Our v, this will cancel out. Our v will become 3.44 meter per second as the final answer at that given point. So in one dimension, it means that these objects before collision and after collision, they're going to move in a straight line. Now, the next question that we're going to look at this point is whereby particles are colliding in two dimensions. And that is exactly the next area we are going to focus on. See you in the next video.